Well, thank you so much, John. Yeah, no, I'm really excited to be here, get a chance to talk to you about how we as a company progressively deliver changes to Octopus Cloud, which is hosted on Kubernetes using Canary deployments and feature flags. Now, one of the funny things about that is a really big mouthful. So I do apologize for how long the title is, but hopefully you're going to find some use out of this particular talk. Make sure I got everything. All right, ready to go. Now, before I jump into the talk itself, John did give a brief intro as to who I am and my job title and everything along those lines. I only have a set amount of time to actually do this particular presentation. So if you do wish to contact me afterwards, please feel free to do so. You can see all my contact information up there. You can also see the QR code that will send you to my LinkedIn profile. So feel free to connect with me on LinkedIn. I'm happy to chat with you before or after. Now, unlike John, I am coming to you from Omaha, from my home office in Omaha. So it is only 9:40 for me. So thankfully, it's a really reasonable time, which I appreciate. I have nothing but sympathy for John for having to be up this late for any of that. I live there with my wife, in case you're curious, and we don't have any kids, but we do have pets. We have a very crazy kitten or kitty. She's 2 years old now. I guess she's not a kitten anymore. That loves to get into weird spots. This is her climbing on our drapes the other day. We also have a dog who loves to play with the cat and chase her around. And this is her actual favorite time of the year because it snows and she loves running around the snow. She would sit in the snow and roll around the snow all day if I gave her a chance, which wouldn't be good for her, but she absolutely loves it. Now, in the summertime, when I'm not spending time with my wife or my pets, you're going to find me out on the bike. So if you've never been to Omaha, Nebraska, if you're curious about what it looks like, this was taken about 10 miles outside of one of the cities out in Nebraska. So as you can see, lots of open sky, lots of cornfields and trails. Now, in terms of my technical background, I started off as a developer back in the very, very, very early days of .NET. In fact, I remember being in a university lecture hall one Saturday morning, listening to a Microsoft representative go on and on about how great this brand new thing they're about ready to release called the Visual Studio. And this is before Visual Studio even had numbers associated with it. It was just called Visual Studio .NET, and they were super excited by it. Since then, I started off as a junior developer, just right out of college, didn't know anything. Became that seasoned developer that just knew enough to be dangerous. Became a lead developer, and then eventually an architect. Now, throughout my career, I eventually started falling in love with continuous delivery and all the problems that it solves, because I had to do deployments at 2 a.m. And through my journey of continuous delivery and being a developer, I came across Octopus Deploy, and when I was given a chance, I jumped right at it to join the company. Shameless self-promotion. I can't help myself. Some of the topics that I'm going to be talking about today, specifically around feature flags, trunk-based development, and so on and so forth, you can find in a white paper that I released this year. So if you go to that QR code, it'll take you right to that white paper, or you can just go to octopus.com/publication. So again, shameless self-promotion. I can't help myself. So let's get into the actual session itself. So what are the goals? What can you expect to learn from this particular session? So for the first one is I want to help provide you solutions that you can apply in your day-to-day. Now, hopefully your use case is fairly similar, and generally it should be, you're hosted on Kubernetes, maybe you have a SaaS platform or something similar, or you need to progressively deliver changes. I also want to debunk the myth that Canary deployments means routing traffic. All too often, I go to conferences or I see these webinars where they'll just do a Canary deployment and they'll say, I'm just going to route 10% of my traffic to this new version of my application. Where in reality, that doesn't work all the time. And we'll get into the reasons why in just a second. And I also want to help illustrate why it's so important to separate the concept of deploying new code from releasing new functionality to our user base. And then finally, this is not a sales pitch of Octopus Deploy. I always have to throw this in here as my disclaimer. Although this is an Octopus Deploy conference, a lot of the things that I'm going to be talking to you about today, you can apply whether or not you use Octopus. Now, I hope you do use Octopus. I really do. But that being said, it's not a sales pitch. So let's go into the background and the context as to what problems we're looking to solve and why we opted to do these things. So as you may or may not know, Octopus Deploy is a self-hosted as well as a cloud offering in terms of what we offer to our customers. Now, what you may not know is that our self-hosted option existed years before our SaaS offering. We used to give customers an MSI that installed on their Windows machines, happy days, everything went well. But then as time went on, we'd hear from customers, it'd be great if you had a SaaS offering. It'd be great if you had a SaaS offering. And eventually in 2017, we heard enough of the, like, it reached kind of like that critical mass, and we made the decision, yes, we're going to have a SaaS offering. Now, because we have both a self-hosted option as well as a cloud offering, one of the key tenets that we have is we want to make sure it's still as easy as possible to set up in a self-hosted environment as it is easy to create something brand new in the cloud. All too often, like there's a SaaS offering we've seen from companies where the SaaS offering is super easy to get set up, but if you have to do self-hosted for company regulations or uh, policies or any of those laws you have to deal with, um, you end up having to set up all of this infrastructure around the self-hosted option. And, we wanted to make it as easy as possible. So with that being said, that also leads us to our architecture in terms of Octopus Cloud, because what we decided was every customer gets a dedicated copy of the application, and we call that a cell. And so the reason why we call it a cell is think of like your human body, where you have cells of different sizes. Just like we have customers that use Octopus Deploy in different ways. We have some customers that do a few deployments a day, and that's perfectly fine. And we have other customers who do hundreds or even thousands of deployments per day. Now, as you can imagine, the customers that have to do thousands of deployments, they need a lot more compute resources than customers who do maybe a few dozen deployments. And so what this allows us to do with this cell-based architecture, where every customer gets a dedicated copy of the application, dedicated database, as well as dedicated file share, is we can adjust the compute resources to better match their use case. And the other reason why we did this is it also guarantees isolation and prevents the noisy neighbor. So when it comes to noisy neighbors, one of the biggest concerns we always have is what happens if one customer runs a query that blocks all of the other customers. In a case where everyone was sharing the same database or the same compute resources, that's entirely possible. In fact, I worked on an application where that did happen more times than I like to admit. And so by doing this, we prevented the noisy neighbor problem. The other reason why we made this decision was it also allowed us to short circuit so many of those conversations where is my data intermingled with my competitor and so on and so forth. So what this means, the reason why I'm telling you all of this is that we have over 1,600 customer instances hosted across 3 cloud regions in Octopus Cloud. Now, if you're curious about our Kubernetes configuration, we're hosting it on just a small handful of clusters when it's all said and done, which is pretty impressive. Each cluster can host about 300 to 500 instances, and it really depends on where the cluster is located. So the clusters that are located in Australia, for example, they don't have nearly as many customers as the ones that are located in the Americas, for example. And that's just common sense because there are a lot more people in America than there are in APAC. And the other thing that we've made the decision on is that the cloud customers will always get the latest features first. So I have a screenshot that's a little bit out of date, but it still illustrates the point that I wanted to make, which is cloud is always 1 quarter ahead of our self-hosted customers, meaning that as you can see here, we released the latest version, which at the time was 2025.2. We released that in February, but the self-hosted version didn't become available until June of this year. So you can see there's a pretty wide gulf. And what this does is allows us to add new features and functionality. Okay, so let's talk about some of the self-inflicted challenges that we have. Now, one of the big challenges that we have is that we have 1,600 customer instances. And reasonably, customers would want us to keep those instances running when they need to do production deployments or when it's important to them. Now, when it's important to them is going to vary across every customer. Some customers, they're fine if their instance is upgraded in the middle of the day at lunchtime, whereas other customers like, no, wait until my nighttime or my 3 a.m. But each customer's 3 a.m. could be vastly different. So my 3 a.m. is vastly different than John's 3 a.m., for example. So as a result of that, if we look at when we allow customers to upgrade or when they've told us when it's appropriate for customers to for us to upgrade them, excuse me, you can see this. This is what's illustrated in this particular chart. So this shows all of the instances along with their maintenance window. And as you can see, at no point do we ever have a situation where a customer isn't in a maintenance window throughout the entire day. And we made it super easy to configure because, again, this is something that we want to make useful to our customers. But we have a couple of challenges. I picked this screenshot in particular, although it is relatively old, but it still highlights the big point, which is that we can do multiple deploys per week. And the reason why I picked this particular screenshot is, in fact, we did multiple deploys per day, which can be really challenging when it takes 24 hours to, at the very least, to upgrade every single customer's instance. In addition to that, we're also releasing new features and functionality. We don't like to do big bang deployments when it comes to our Octopus Cloud customers, where we just release all of the features all at once, because that's more of a self-hosted approach. For our cloud customers, what we like to do is we like to release new features and functionality throughout the entire quarter when it becomes available and when we think it's ready for them. So one feature might be added at the very beginning of the quarter, or one feature might be added towards the end of the quarter for that particular release. Now, this required a complete mind shift for us when we went to our SaaS offering. So in the early days for our self-hosted customers, the upgrade cadence that we saw was it could take anywhere from a few weeks to several months before we kind of reached critical mass with our customer base in terms of when they upgraded. And so this was a very long tail, so to speak. And so typically what would happen is we would upgrade all of our staff instances, test everything out, and it looked good. And so we'd release it onto the world, and then it would take a period of time. Now, that completely changed when we went to SaaS. What used to take maybe even a month or two now became 24 hours, which is a big mind shift for us. And so one of the big things that we saw, especially at the very early days of SaaS, this is one of the biggest problems we ran into, which was we started upgrading, say, all of our instances at 10 a.m. Brisbane time, which is 12 a.m. UTC. And sometimes what would happen is a critical bug would be found. And at the time, especially at the very beginning of our SaaS offering, we continue upgrading all of the remaining instances. And that obviously wasn't an appropriate solution, but that's just something we ran into. And so I want to dive into our initial solution of how we solved this particular problem. The first thing that we ran into was we wanted to make sure that we prevented what we call show-stopping bugs from reaching all of our stable customers. And so we created Canary deployments, or we had release rings. But it's the same core concept as a Canary deployment, which the Canary deployment, the idea is that you find a problem with a subset of customers or a subset of traffic or a subset of users, and then you stop and you either revert or you do some sort of action. But the idea being is you can minimize the impact that you have on your user base. And so what we did is we have our staff users, they're always upgraded as soon as possible. And then after a day, assuming the staff users didn't find anything, then we'd upgrade all of our insiders. And after another day after that, we'd upgrade all of our another 7 days after that, we'd update all of our early adopters. And then assuming the early adopters and the insiders and the staff didn't find any issues during another 7 days, then we'd upgrade all our stable customers. So what this meant, and this is a pretty common for a lot of Canary style deployments, which was it's not a few minutes when you're routing traffic. Oftentimes for us, it's multiple weeks. We're talking 2 weeks before a new version reached our production released, excuse me, reached our stable customers. And we also needed a way to stop in case an issue was found, even if we got all the way up to the stable ring, because again, it could take up to 24 hours to upgrade everybody. And so we looked around, and if you're familiar with the DevOps Handbook, as well as the Phoenix Project, as well as the Unicorn Project, they talk a lot about Toyota. And Toyota came up with what's known as the and-on cord. And the and-on cord sits above everybody's workstation. And anyone can pull that cord. And when they do pull that cord, it stops the assembly line. Now, the reason why Toyota did this is because they wanted to prevent a small problem that the assembly line worker can notice and say, this is going to be a problem, from becoming a catastrophe, which could involve a recall, image problems, any potential lawsuits. So this allowed them to do that. Now, this is a gross oversimplification of the end-on cord. It's actually a lot more nuanced as to when it does actually stop the assembly line. But generally, that's the most important thing to know, is that when you pull the cord, anyone can pull it and stop the assembly line. And so what we started to do is we started treating our releases and our deployment pipeline like an assembly line, where we're always going forward. And we're always assuming that it's going to be successful. So we call it the enthusiastic promoter. So we just constantly treat it that way. We're always pushing forward on something like that. But we need a mechanism to stop. And so we built the and-on cord ourselves. It's an internal tool that we built. And this screenshot I took right off the user interface. And what we did is we created a sense of psychological safety. And that's the most important thing, is to have that sense of psychological safety to pull the cord to stop it from being released. And so we said, who can pull the cord? Anyone. Anyone can pull the cord. That means you. I've pulled the cord myself. I've pulled it a few times. And we have a list of like pretty common criteria. You can't deploy, you can't edit or create run book or deployment processes, can't edit or create releases, and so on and so forth. So we kind of provided a quick handy guide. But generally, if you're not sure, pull the cord. Because what this does is allows us a chance to stop and research and make sure that, okay, if this is a big problem, it's a good thing we stopped it. Or if it's not a big problem, we just unpull the cord and it proceeds on with its merry day. And we'd much rather pull the cord and be wrong than not pull the cord and have something get out to production that causes even more problems. And as you can see, we've pulled the cord when I took the screenshot 549 times. So it's a fairly common occurrence. This isn't something that we're like, oh my gosh, only pull it in case of an emergency. No, it's like we will pull it fairly often. So what this looks like is that if a critical bug is reported, even when we get all the way up to their stable customers, we can stop upgrading all of the other instances, which was incredibly powerful for us. But while this worked really well, we started noticing some cracks after a short period of time. So I'm not going to read the entire thing to you, but the big takeaway from here is one of the engineers noticed that in 2022, we had a period of time where it was 46 days between our last release to production and what was going to be promoted to production. Not only that, best case scenario, he's saying it's probably going to be another week, assuming no other further issues. So what this means is that although we had 15 days to kind of quote bake in the changes, what we were finding is even then it wasn't long enough. And we actually even got up to over 50 days in this particular case, which was just not acceptable because you can't be a company that's trying to deliver value fast to your customers if it takes over 50 days to even make it all the way through a production rollout. So what went wrong? Why was this happening? The truth was is that even if we waited until the very, very, very end, and there are a couple of customers that are in the what we call the laggards ring, which they get upgraded at the very end for a variety of reasons, even then they were finding issues. And this highlights one of the core problems with Canary deployments, which is that they're used as a way to de-risk new features and functionality. But in reality, they should be used as a way to de-risk whether or not a deployment will be successful or not. And what I mean by successful is I'm able to deploy it. I run all my database migration scripts. They all came back positive. I was able to run a series of very small tests. Everything looks good. The application is running. Okay, I've moved on. So that's the type of thing that a Canary deployment can help you do, is they can help you de-risk whether or not the deployment will work. But it will not de-risk whether or not a new feature will work. Because the truth be told, as you can see here, is that even though we had 15 days to let code quote unquote bake in, it still didn't cover all the possible code paths. And this is one of the critical problems with Canary deployments is that even if you route a subset of traffic, let's say 10% of traffic or 15% of traffic, there's no guarantee it's going to cover every possible code path. And that was a big problem because there's always going to be those use cases that you didn't think about, which is that happens, or it's a edge case that you thought was an edge case, but in fact was a much more common use case, or there could be any number of different things. Could be a performance issue, could be any number of those things like that. So when we looked at it, we started saying, okay, what's the number one reason for these show-stopping bugs? And it was new features and functionality. Now, I've been responsible for releasing what I thought was a bug fix that created even more bugs, but that's more of a rarity. That's an exception that kind of proves the rule. More often than not, more often than not, new features are the reason for show-stopping bugs. So let's talk about solution V2. Where are we at today? So the first thing that we did is we shortened the release rings. You saw that we actually got rid of the insider release ring, as well as we changed around our Canary deployments. So we have our staff instance, and the very first thing that we now upgrade is our main deploy instance. So we use Octopus deploy to deploy Octopus deploy. And that deploy instance, that main one, that's the very first thing that's upgraded. And that allows us to test it out because if it doesn't work for us, it's definitely not going to work for our customers. We know that for a fact. And then at most, after 3 days, we will deploy to a random subset of instances. It's always rotated, it's always randomized. And again, this is at most. More often than not, it's actually about after a day, if I'm being completely honest. And then when it comes to our stable rings, then we'll upgrade all of our stable customers, and then finally we'll upgrade our laggards. But again, I'm talking like what you're seeing here is absolute worst case. More often than not, it's typically now we're getting it pretty fast. Now it's down to about, I would say about less than a day, a couple days at most. But what about new features and functionality? So I want to highlight something that's really visible when it comes to new features and functionality to really illustrate this point. So this was our user interface at the start of 2024. And this was our user interface at the end of 2024. Now, as you can imagine, it was a pretty big change when we made this user interface change. There were a lot of moving parts, a lot of things that we simplified, we moved some things around. It was a big change overall. Now, in a traditional Canary deployment, it's like, oh, I'll route a subset of traffic, or I'll have a randomized subset of customers who'll get this new feature. And that just doesn't work when it comes to big new features like this. Because could you imagine as a user, if this is what you saw when you signed in, like it looked like this, not exactly like this, but it looks similar to this. And then you sign off for lunch and you come back after lunch and the user interface looks like this. As a user, you're going to be pulling your hair out because you're going to be like, what is going on? Why is this interface changing so often? Yes, this is a dramatic example, but the point is still holds. However, we needed to be able to get feedback before updating all of our users because with new features and functionality, we want to make sure we're building something that's useful for our users. And if it's not, we need to know about it right away so we can adjust. Now, there's two schools of thought when it comes to how we're going to get feedback from our user base, specifically a subset of our users, ideally, because we want to make sure that this is going to work before just updating everybody. So the first school of thought is let's go ahead and let's create a feature branch for those particular users. And that is an approach, but the big problem with that is those branches typically live for a significant amount of time. And we actually saw this happen within Octopus Deploy with one of our features, which was our Spaces feature that we released in 2019. That was being worked on for almost a year, if not a year. And when we merged it in, because it was in its own branch, and they were dutifully merging main into their branch whenever possible. But when they merged in their changes, it's an interesting time to say the least. So having a feature branch and giving that to our users just wouldn't work. The other thing is we want to be able to let our users test the new feature in production. And there's often cases, where we are working on multiple features at any point in time. So this is where we started investigating feature toggles. And we built our own initially, but then after a while, we started looking around and we came across OpenFeature.dev. And if you're not familiar with OpenFeature.dev, what it is, it's a CNCF project, and it's a specification on how feature toggles should work. So what they do is they provide a specification as well as they provide SDKs that plug into providers. And so your code, what it does is it interacts with the SDK. And then the SDK, that's what's going to interact with the provider. So your provider could be Feature Flags R Us, it could be not just OpenFeature, sorry, Launch Darkly. It could be any number of those types of providers that are out there. Now, one of the benefits of OpenFeature is that you can target a segment of users with a particular feature toggle. So it could be based on location, it could be based on a team, it could be based on usage history, whether or not a user signs up, any number of those things. And it's really up to the provider as well as your application to kind of define what those segments would end up looking like. Now, one of the other things that OpenFeature also provides is a really robust lifecycle management when it comes to evaluating feature toggles. So it's incredibly robust when it comes down to it. Now, what does this look like when it comes to how we deploy? Well, the first thing that we do is we work on a new feature and we will incrementally build this over time. So think of a house. You don't just show up one day and build a house in one day. That's nigh on impossible. You have to, dig out the foundation, lay the foundation, all these other things. So it's a period of time. It's a small series of changes that happen each day, and at the end of a few months, you're going to have a house. The same thing is true with how we work on our features. We will incrementally build features and functionality, and what we'll do initially is we will add them into our main branch. We'll merge them into the main branch, but they're hidden behind a feature toggle. And so what we'll do is we'll initially deploy with the flag turned off. And then eventually we'll kind of reach a point with the feature where we say, okay, we think it's ready for our staff users to start using. And so we'll turn it on for our staff users. Sometimes it's a subset of staff users. Most of the time it's for everybody. And what this will allow us to do is then we can start testing it out ourselves, start using it, start building up what does documents look like, what are best practices, what are the rough edges, any sort of those different types of things. And then once we kind of reach a good stable point within our staff users, then we'll turn it on for our early adopters. And the early adopters, they can opt in. Now, one of the benefits of this is that we actually had multiple early adopter programs running, especially at the beginning of the year, for multiple significant features, which is pretty cool. Um, Now, the other really important thing is that we stop right here for sometimes weeks, if not months at a time. To give you an example of a time frame when it comes to this type of staff early adopters, Platform Hub, which we just released to the vast majority of all of our enterprise customers this month, I had access to that dating back to February. That's how long we will have a feature toggle in there, and that's how long we will build out the feature and we'll test it and we'll make sure it's going to work. And we find all the sharp edges and so on and so forth. But then when it's ready for the rest of the users, not just the early adopters, that's what gives us the capability to then start enabling for the remaining users over a period of time. Now, one of the big advantages of this is that we can also pause rollouts when issues are discovered. So when we were rolling out the new user interface, for example, we had a couple of users report to us that, hey, we're running into problems. And when we run into problems, it gave us a chance to pause the rollout and start evaluating. Is this a common use case? How many people do we expect for this to be impacted? Or any number of those different things. And then in this particular case, we said, well, this actually only impacts a subset of our users. So we're going to go ahead to continue on to 100%, but we will exclude those other customers, the ones that are running into issues or we think will run into issues, until we resolve this particular issue. And so it kind of gives us this very kind of controlled way to roll it out. Now, it looks like it's controlled for every single feature, but depends on the feature. For, say, the new user interface, it was very regimented. I think it was like 5% of the time. We were rolling out just 5%, then 10, then 20, sorry, then 15, then 20, 25, 30, and so on and so forth. But for smaller features, it could just be 5%. It looks good. We're not seeing any big issues. Let's just push it out to 100%, because it could be like you have to opt in for the feature or you have to configure it in some sort of way. And so in case you're wondering, this is what it would look like with our feature toggles. And in fact, this is within Octopus Deploy. We're starting to build this out there. So kind of giving a sneak peek as to what it could be. And so for us, our segments of what we do, it's specific tenants or specific customer instances. Now, this has had a number of big benefits for us. The first big one for us is this has had a noticeable impact on our uptime, because we have separated the concept of deploying new code from releasing new functionality. So when we deploy new code, the chance of it going wrong is incredibly rare, because anything that could potentially cause a problem, aka new features, well, those are hidden behind feature flags. And so our uptime when it comes to our Octopus Cloud customers has is significantly higher than it's been in the past. In fact, you can see for several months we exceeded 99.99. I only blame last month. I blame October. I blame that on the Azure outage that occurred when I was at GitHub Universe. But so it has had a noticeable impact on our uptime. It's also had a noticeable impact on our lead time to changes. And this is actually a fairly old screenshot. And you can see that when we track this, and our goal is to get down to 1 day. But the biggest impact that it's had is this has been the thing that's unlocked for us trunk-based development. And this is what we've come to realize, is that this is the best way to build new features and functionality, is that feature toggles allow you to do this because what you can do is you can incrementally build new features over a period of time. So again, instead of trying to build the entire feature, what you might do is first you might just say hey, we just want to add a new page. Let's add the page, put some basic layout on it. Okay. Now let's add a button onto that page and have the button maybe just do something really quick. Okay, now let's actually have the button do something. And so those are each check-ins and then merges into main, and then we push that up there. Now, the benefit of this is that it also means that when a bug is discovered, it's just the same workflow. It's done in a short-lived branch, it's merged right into main, and we can push it out there. And this is the idea being is that with trunk-based development, is you're making very small changes, and so your delta for each release is incredibly small. And yes, you might bundle up, say, several merges into main and deploy once a day. That's perfectly fine. But this really allows you to deploy once a day and know that, hey, the amount of changes that are going out are very, very, very small. And so the other advantage is that there's also less of a chance of having to roll back because, again, the delta is really small. But that's not saying it's all sunshine and rainbows because there's going to be remaining challenges with this. One of the big challenges that we have is mean time to recovery. Once we detect an issue, the time to fix is very quick. We can fix an issue, and our goal is under an hour. Again, with short-lived branches, that's completely possible. But the time to detect can range. Sometimes it could be 5 days, it could be a few days, it could be any number of those different types of things. And so this is something that it's an ongoing challenge. This is, every time we iterate and improve upon this. One of the iterations I saw that came out recently, I would say earlier this year, was we started anytime an exception is thrown by any of the instances, it's logged. And then we start collating all that information. We start looking for new exceptions. So if a new exception is discovered, then we start surfacing that information because there's always going to be exceptions, and that's an unfortunate truth. But some exceptions are known and some exceptions are brand new, maybe because of a new feature. So we want to surface that information whenever possible. And this isn't going to prevent every single bug from being released out there. This is the high severity defect escape rate. And what this does is what we're doing is we're tracking anytime a Sev 0 or Sev 1, meaning a show stopping bug, was discovered. And we have the andon cord, we do a retrospective, it's blameless retro to make sure that this was the reason, this is how we're going to fix the problem, make sure it doesn't happen again. And we want to make sure that that is very, very low. But it's at the same time, it's not an impossible thing to happen. So that can still happen even with all the guardrails that we have in place, even though we have a ton of automated tests, even though we use, you know, trunk-based development and feature toggles, those issues can still get out there. And that's an unfortunate truth, but that's just kind of how software works. Now, we're not going to treat every issue the same with this because there's some issues that are like, oh, you misspelled this word. Yeah, that's an annoyance. It kind of makes you look bad, but it's not the end of the world. Whereas I can't deploy or something like that. Now, the other big challenge that you're going to run into is that feature flags, it requires the expand and contract pattern. This is a very disciplined approach to adding code, meaning that you're going to have to expand your code base to add the feature toggles and make sure that everything is going to work and run the appropriate tests. And you have to do it for both the positive case as well as the negative case, meaning when it's turned on as well as when it's turned off. So you're going to have to add that. And then at some point in the future, you're going to have to contract your code base. You're going to have to remove the negative use case when it's turned off, as well as all the appropriate tests for that. And that does require a bit of discipline. And so you almost need a forcing function that forces you to have to do that. Now, for us, oftentimes we remove the feature toggles before they're released to our self-hosted customers. So that's a nice forcing function for us, but that's not always the use case. And so what this ends up looking like is that there's always going to be this this overhead that occurs. And so you're going to have to make these decisions yourself as to when it's appropriate to use these feature flags or feature toggles. Because there's always going to be the clear cut, for example, the brand new user interface or platform hub. Absolutely, 100% we're going to have it behind a feature toggle. Those are very easy to say yes to. But at the same time, you're also going to have to worry about what about the overhead on top of that? Are we going to have to do things like, reduce the code and have to go back through and clean everything up? And is it worth the overhead? Is this worth all of the time and everything along those lines? And so those are discussions that you'll have to have internally, because there's always going to be the clear cut yes and the clear cut no, but there's always going to be that messy middle in between on something like that. So key takeaways from this session. Canary deployments, they are fantastic at de-risking deployment failures, but they're not fantastic at de-risking new features and functionality. So again, what I mean by a deployment failure is, can I deploy the thing? Will it run? And if it doesn't run, okay, that's, I want to make sure I resolve that. But it's not going to be good for de-risking a new feature like a brand new user interface or a brand new feature like Platform Hub. The safest deployment strategy that you can have is when you separate deploying new code from releasing new functionality. And this is because the number one reason for all show-stopping bugs is going to be when you add new features to your code base. Treat your deployment pipeline like it's an assembly line. Always keep moving forward and use trunk-based development, because you're going to make small incremental changes on something like that. But again, provide the psychological safety to allow anyone to stop that assembly line if you need to. Don't treat it like they did something wrong or anything like that. Treat it like this is a good problem to have, and we need to resolve this. And truth be told, when it comes to rollbacks, feature toggles, they provide the best rollback strategy. Because with Canary deployments, you're de-risking a deployment failure. And if a deployment failure starts happening, well, you don't proceed. You go back to you don't even let people get onto the new version or anything along those lines. But when it comes to new features and functionality, feature toggles are the best because it allows you to turn off a particular feature. And one of the big challenges we always see with rollbacks is when you roll something back, every change goes back. That means bug fixes, security patches, everything like that. But again, with feature toggles, you can be very targeted in whether or not you want to turn on a feature or turn off a feature. So it's of all of the options that you have available, it's far and away the best. So thank you very much for your time. I really appreciate it. Again, if you have more questions or if they come up, please feel free to reach out to me, as well as please feel free to grab the white paper. I have the QR code for both up there. Thank you very much.
Awesome stuff. Thank you, Bob. We had a couple of just comments that came in. First, we had Tony mention your achieving continuous delivery with TPF. This is obviously a white paper you had written. You can find this up on our publications site. Can you tell folks a little bit about this?
Yeah, absolutely. So a lot of the things that I talked about today, which was trunk-based development, trunk-based development, progressive rollouts such as Canary-styled rollouts, as well as feature toggles. Everything I pretty much talked about today, it's the white paper to kind of really hammer home why it is the best solution when it comes to continuous delivery.
Fantastic. And as Joanna points out, you'll find additional white papers at /publications. Steve also made the comment here that it's great to see this being used at scale in the real world. This is such a thoughtful approach.
Absolutely. Yeah, it solved a very interesting problem for us. So we're really happy that it's out there and we show that it can work.
Fantastic. And so you can either scan the QR code if you're so inclined, or you can visit /publications if you're wanting to find out more. Don't forget to connect with Bob. You can see all the socials there. You can also connect to him through the QR code. Any final words before we move on to our next presentation there, Bob?
Nope. Thank you so much for your time. I really appreciate it.
Awesome. Thanks, Bob.